ranking cycle.
All right. Good morning, everyone. Today I'll be doing the Rankine cycle experiment. We're going to do that next week. Brief overview of what I'm going over, just how this experiment is related to thermodynamics, and what we're looking to get out of doing the experiment. I'm going to go over the apparatus itself and the procedure for running the experiment, and then some required calculations that the group reporter is going to have to do, and predicted results. So I did some sample calculations that I'll show you as well. So how it's related to thermodynamics, one of the major aspects of thermo is converting heat into useful work. So how we do that, Mr. Rankine back in like the 1850s came up with this cycle. This is an idealized version that I'm showing here in these graphs, but as you can see, going from 1 to 2, if you follow along in the TS, you're going from 1 to 2, you're going across your pump, you're increasing your pressure isotropically. Again, this is ideal. It's not quite going to be like that in a real case. Going from 1 to 2, you're going to end up a little bit to the right of your constant pressure line, and going from 3 to 4, you're going to end up a little bit to the right as well. Going from 2 to 3, you're converting your water into steam through your boiler. Going from 3 to 4, you're going through your turbine and getting your work done. And then after your turbine, we need to condense the steam back into water to run back to the pump so that we don't cavitate it. So what are we looking to get out of the experiment? Obviously, we want to understand how to operate a Rankine cycle, not just fundamentally how it works, but actually operating it, understanding, and seeing it right in front of you, controlling it. We want to obviously measure some relevant data, this is what all experiments are for, and calculate the typical parameters that we normally would. And then obviously application is estimated that Rankine cycles produce about 90% of all of our electricity, so it's kind of a big deal. All right, so the actual procedure, this is the apparatus. We start off with most of these switches and off. I'll get to kind of each one as we go along, but pay attention please to the steam emission valve. I'm going to leave that open, and the front boiler door. I'm going to make sure that's closed and latched, and the caster wheel should be locked. Nice. So after all that's set up, we move on to step 1, and that's we need to drain the boiler and condenser. We just need to get rid of any leftover water or anything that was used from the previous experiments. Next, we would fill the boiler with about 5.5 liters of clean water. This is why we need to leave the steam emission valve open, is to allow air to escape from the boiler when we're filling it. Next, we would leak check our fuel source, so we can close that steam emission valve, and we can try our fuel regulator and open that. And we want to listen for any hissing sounds or smelling any kind of a rotten egg odor. That'll indicate that we have a leak. Next, once that's good, we can turn on these switches in this order. Gas valve, this is your operator gas valve right here, and then our burner and master switches. Turn those on. Once that's on, the burner should kick on within about 45 seconds. If not, we may have to do a system purge. I don't have enough time to get in what that is. That's all good. We'll be monitoring our boiler pressure, and we should see positive boiler pressure within about 3 minutes. Our pressure gauge right there. Once it hits about 110 psi, we're at our steady state. That's where we want to be, and we can move on to preheating. So preheating, one more please. So that's what we're going to do, just to kind of prepare the experiment for running what we want to do. So we need to reopen the steam emission valve. That's going to allow steam to come out of our boiler and start running through our turbine and turn our load switch on. And then we can adjust our load rheostat in order to maintain just under 10 volts. Next, please. And that's going to reduce our pressure in our boiler down to about 40 psi. Once that happens, then we can close our valve again, and that'll allow our boiler pressure to come back up. And then we can move on to the experiment, which is just adjusting the steam emission valve to kind of change the current and voltage that are coming out of our generator. So this is the data that we need to actually record. So after the experiment's over, we'll have to measure the volume of the condensate that we used and all the water that was used in the experiment. Sorry, condensate collected, and the boiler water consumed. So we'll also be measuring fuel flow versus time, boiler temperature, turbine inlet and outlet pressure and temperature versus time. We'll have to know the turbine RPM and the generator voltage current over time. The equations that we'll have to do, so first we'll need to find the heat that's putting into the boiler to convert to steam, which we just find by taking the difference in enthalpy before and after the boiler. We need to find the power of our turbine, which is our mass flow rate, and multiplied by the difference in enthalpy before and after our turbine. We need the efficiency of our power generator, which is the power generated, which we can find by voltage times current divided by the power of our turbine. Q out of our condenser, and one more, the total thermal efficiencies. So I did some sample calculations. I assumed the mass flow rate from a report that was some other universities did. That was their typical values. And in the pressure, that was given in the lab manual, and I assumed the other temperatures should be reasonable values. So the sample calculations themselves, the heat into the boiler, that I put this 4 times. And there's one more. And these are my numbers. You'll be able to go and read these afterwards if you choose to do so. That concludes.